We're going to do one more. So, yeah, we still have time. So we're going to do one more of these. So go back to letter A. All right. All right. The water wheel shown has a radius of 7 feet and rotates at 6 revolutions per minute. One revolution every 10 seconds. Very good. Okay. So you start your stopwatch when the point P, so this point right here on the rim of the wheel is at its greatest height. And right at this point, we're going to start our stopwatch. We want to sketch 2 complete periods of the sinusoidal function that models the distance of point P from the surface of the water. So this is a water wheel, and you can see this line represents the water level in terms of the number of seconds. So what I want to do is we're measuring the distance that P is above the water. So at the very highest point, how high off the water is point P? 13. 13 is the winner. Why is it 13?
Well, it starts at 6, but then you go 7.
Because the radius is 7, so that's 7 for the radius and 6 feet above the water. Very good. So our very highest point is at 13 feet above the water. So P is going to circle around and come down below the water. How low does it get? What is its lowest? 1 foot below, which you would denote with -1. Okay. And then it returns back to its highest point of 13. So let's see. I'm going to go ahead and mark 0 in here because that is the level of the water. And I think that that's good to know. Let's see. What's the midline? 6. The midline is 6. You can get that a couple of ways. You can do it halfway between the low and the high. Or you can think, oh, it's 7 above and 7 below. And that happens to be the radius. So it turns out the amplitude of a function is the radius of the circle. That's the drawing. Okay. So I'm going to draw in that midline. It's a dotted dashed midline there. And this is our horizontal axis is representing the time. So right at time is 0, my point P is 13 feet above the water. And it's going to travel all the way around the circle. And how long does it take to get all the way around the circle? 10 seconds. Because it does 1 rotation every 10 seconds. So at 10 seconds, where is my point P? After 10 seconds, where is it? 13 feet again. Very good. So how long does it take to get to its lowest point? 5 seconds. And so at 5 seconds, how low is it? Negative. At 5 seconds, it's -1, 1 foot below the surface of the water. And ladies and gentlemen, you just graphed 1 period of this cosine function. Oh, yeah. So it turns out that cosine functions, we really don't care about the middles. As long as we have the high and low values, we've got a good cosine curve. We've got enough information. So we want to graph 2 complete periods. Well, this was 1 period. How many seconds would 2 complete periods take? 20 seconds. So right now at 10 seconds, and then at 20 seconds, where is point P going to be? Back at 13. How many seconds did it take for it to get to its low point again? 5 more seconds. That puts us at 15 seconds. Yeah. So when we're doing cosine curves, we really just need highs and lows, and we can do really good curves. Okay. You could subdivide if you wanted to, but it's really unnecessary. Now, we have enough information here. The vertical shift, also known as the midline or D. What was our midline?
6.
And the amplitude is 7. And the period. The period is 10. That's the time it takes to complete one cycle. So what's B? 2 pi over 10, which is pi over 5. All right, so then to write our equation, we have amplitude of 7. Is the A value 7? Yeah. So 7 cosine of B is pi over 5 times x, although we don't have x, we have t because we've got time. And you'll notice this one started at 0, so we don't have any left-right shift. There's no c value here. And then plus our vertical shift. And so this is our equation, which is great. We want to use our graphing calculator to determine when point P is on the surface of the water during the first 20 seconds. So I drew in the surface of the water. We want to figure out for point P to be on the surface of the water, that's when our height is 0. And so we're looking for these points where our point P is going to hit the water. We can do that on our calculators pretty well. We're going to go ahead and type in our equation. Let me tell you a few things about your calculator modeling that we've done here. First of all, if you're going to go graph anything again, you need to turn plot 1 off. So go back to y equals and turn that off by hitting enter so it's no longer doing this data. And go ahead and clear out these equations. I'm going to type in 7 cosine of pi x over 5 plus 6. And I want to know when it hits a distance of 0. So I'm going to put that as my second equation because it's easier to find that using the intersect feature of our calculator. On the Casio, it's super easy. You graph and then calculate the intersection. You just press intersect and it just gives it to you. It's really cool. On this calculator, we're going to go ahead and graph this, but I want to make my window appropriate. So we're going to change the window to match what we've graphed. So I'm going to change the window. I want my x values to go from like 0 to, say, 20. My y values to go from negative, I'm going to give it some space, negative 5 to like 15. And then you can hit graph. And so I can see all of these points right here where the point P is hitting our water level. And so we're going to calculate the intersection of our two equations. So to do that, you're going to go to the calculate menu, which is a second function. So you're going to do second calculate the intersection. Oops, I passed it. The intersection, and just use the left and right arrow keys. So move the left arrow key to move Tinkerbell to that first intersection point, which you can't quite see. There it is. Sorry about that. Okay, there you go. So you move Tinkerbell right to that first intersection point and just hit enter, enter, enter. On the Casio, you just, it's so easy. Just does it. And so that's the first intersection point at 4.14 seconds. 4.14 seconds. If you're off a little bit, that's not a big deal. All right, now I want to find the second intersection point right there. So again, I need to run that again. So second, calculate the intersection. Calculate the intersection and move Tinkerbell over. And again, enter, enter, enter. And that's 5.86 seconds. And I get to go over here and find this one, and then hopefully I'll see something. I'm going to calculate the intersection again. And move Tinkerbell. Plus 10 seconds. Very good, sir. Very good. That is the symmetry in these curves is very cool. Yeah, so 14.13 or 14.14, 10 seconds more. 14.14. So what's the last intersection going to be? 15.86. Yeah, seconds. All right, so that's very interesting. One more thing about your stat graph data. Go back to stat and edit. And to clear your list, I'm going to teach you how to do this so you don't mess up your calculator. You're going to arrow up to the very, very top where it says L1 and L2. And then you're going to press clear and enter. And it'll clear the whole list. Do not press delete. Because then you'll just mess everything up. And I'll have to reset your calculator. So you're going to do clear and enter to clear your list. On the Casio, I think you just have to press delete, 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 and delete each entry button. All right, ladies and gentlemen, don't lose this. You're going to need this worksheet for Monday to work on your project.